Good evening. Am I audible? Good evening. Am I audible to you?
Yes, sir.
We can hear, sir.
Okay. So shall we start the presentation today, the emerging technologies. Now I will prepare a few slides today. Hope you are, now it is visible to you. Right. Now, today we know we are in the era that a lot of technologies evolving. So it is never ending. Sky is the limit. So today my session is not to tell you about a specific technology, because actually it is not the time, and time is not sufficient to do that. Especially sometimes you may be updated in some technologies better than me. Today I'm going to discuss a little bit an overview how understanding the emerging technologies and evaluating those technologies for our purposes. Right? Now, what is the technology? The technology is something that the application of scientific knowledge for practical purposes. It includes tools, systems, devices, and processes. We can get examples, IoT, those placed in the buzzwords. IoT is the Internet of Things. Internet of Things, sorry. We all are aware Internet. Internet is nothing but how the computers are connected. Then how the person can communicate to another person in a far end. Right? Now, IoT technology. We know Internet of Things, it is now being used. Smart homes, smart appliances, and building management systems, and other control systems, in a SCADA systems, it is even biomedical equipments, etc. Now, another one is smartphones. You know how smartphones are evolving now. Samsung and Apple actually main competitors. And another buzzword these days is AI. AI means artificial intelligence. Another one is the cloud computing and blockchain. Now, types of technologies, but is not limited to this one. Now, for example, the information technology. Information technology, it includes software, hardware, networks. Which means now information technology is used by everyone. Maybe engineers, maybe technologists, but maybe non-engineers and non-technologists. And communication technology. Now, with the communication technology, we have come to this stage. Internet, fast internet now, gigabit internet. Then we are talking of 5G. We have transferred from 1G to 5G. Now the many research papers are now you can find in 6G areas as well. Then we will go to the industry. The robots, 3D printing, and medical technology. It is the biomedical, telemedicine, and biotechnologies, and nanotechnologies as well. The other emerging technologies like AI, artificial intelligence, blockchain, and IoT. Now, the latest addition is a digital twin. I think you have heard the digital twin models. I'm going to discuss a little bit about the digital twin if time permits. Now, these are the current technological trends. Now, everyone use this word artificial intelligence and machine learning. What is the difference between artificial intelligence and machine learning? Actually, artificial intelligence means, now, for example, now 5 or 6 decades ago, you can sit before a computer, you can issue a command, that computer execute that command based on the program written by a particular code. It gives output. So computer do not have any intelligence. What you ask, they will do that. But nowadays, artificial intelligence means it is a superset, but the machine can understand, which means the machine to machine communication. Machine can think. So it means the machine can learn. So now you can see the difference. For example, now in a machine learning, right? In a machine learning is a buzzword today, right? Wait a minute. Right. Machine learning is a branch of artificial intelligence that enables computer systems to learn from data and improve their performance over the time without being explicitly programmed. Now, for example, in a machine learning, for example, say if you have equation y is equal to 2x plus 5. If you give the input x, it decide input y, output y. So straightforward, you can program it. But if you use a machine language, you can ask machine, you can train the machine giving data set. When x, what is the y? When x, what is the, for example, you can get the x 100 inputs for the x, 100 output for the y. That train the machine that what is the input between, what is the relationship between x and y. So this is the machine can learn from the data and they can use a particular algorithm depending on the data input and output data relationship. It is called the machine learning. Right? For example, how you can differentiate rat and or mice and squirrel. Because our mindset since the childhood, we have seen these creatures, right? Then our fathers or mothers, they have told us who is the squirrel and who is the mice. So we can, because our brain has been trained for that. How we train? We see it. After that, we got the image. This image, when next day we see that image, our brain tells us this is the mice, not the squirrel. Similar to that. It is called the machine learning. Another one is actually deep learning. In the deep learning, it is like using the large language models. Large language model means actually it uses a neural network. Neural network means it divides into certain neurons, certain layers, only we can visible input and the output. In between that, there are many layers. When you data pass from one layer to another layer, that way you have trained it, then they do learning part, then give the output. So best example is a ChatGPT. So ChatGPT is a large language models. Right? And how this artificial intelligence or machine learning, what are the applications? For example, say if you go with the iPhone, that there is a security feature that image recognition, face unlock on phones, and speech recognition, right? So this is for the machine learning. And sometimes predictive maintenance in engineering. Because machine learning can predict it based on the data. You don't need to write the program, but you will have to develop the model using the certain algorithms. And sometimes the fraud detection in banking. There's a machine language. And recommendation of systems like YouTube, Netflix, and Amazon. For example, in a YouTube, when you watch for detective stories very frequently, when the next time you go there, those things are actually pop up as a priority. Priority is in your account. Right. So in civil engineering, how the machine learning is used, right? It means actually the data sensors, the sensors measure the vibrations, strength and temperature in the bridge. That we can collect the data through the sensors. Then after data, this algorithm in the machine learning, it learns what is a normal pattern. It means every day it detects it. Your machine can learn it. This is my normal pattern. But if one day, if unusual pattern appears due to a crack or stress, The model flags are giving a signal as a potential structural damage. Right. What are the benefits? Which means the early detection of failures, safer bridges and reduce maintenance cost. We go to the mechanical engineering example. In machine learning, we need data. In mechanical engineering example, what the data? A motor or pump has sensors measuring temperature, vibration, and current. This can be used in the water pumping station. Hello. Yes, and I think Mihili Savitma, you are please mute your. Okay, thanks. Because the noise was observed. For example, if you work in the someone is working in the water board or somewhere, if they have seen that in plant training, you have seen. How can I say? It is a water pump. Now, actually, before operating any water pump, it should have sensors measuring temperature, vibration, and current. If something is abnormal, it should be go to the safe mode. But you can do it manually as well. But only the one operator, we have to keep one operator there in the operating room. Right? If the vibration goes. But in here, if you use in the machine learning, you can analyze the signal. The ML model, of course, we'll have to pre-program the model. Only not that computer program you write it, but you use an algorithm. It learns recognized early signs of bearing, wear, or imbalance. So at the beginning, you can say this is our reference model. When it runs, it compare with that one system. So it actually gives alarms. And how it is applied in electrical systems. Data. What are the data? In a historical electricity consumption, weather data, time of day. So you can have the demand side management, the ML using. The models like the regression or neural networks predict how much power will be needed tomorrow or next week. You can see the benefit. So actually machine learning is a broad field where computers can learn data using algorithms. Maybe the decision trees, support vector machines, linear regressions, etc. Right. In ML, machine learning, it requires humans to decide what input features are most important. Humans should decide it first. Example, so predicting house prices. So we must choose the features like area, location, the number of rooms. But in case of deep learning, it learns a feature automatically from the raw data. There is a difference between deep learning and the machine learning. Right. Now, another thing is that in machine learning, it works well with the smallest data sets. Whereas deep learning needs larger data sets, millions of examples, right? To perform well, because deep networks have millions of parameters, millions of variables. So, for example, machine learning we can use to predict energy demand or spam email detection, customer churn analysis. Whereas deep learning, self-driving cars, detecting pedestrians and traffic lights, and now deep learning, of course, face recognition, and natural language processing like the chat GPTs, etc. So you can make the difference that. Right. Now I have done that part. Now, the second part is the Internet of Things. Internet of Things means actually how the things are connected in net. How the things are connected in net. For example, now, if you want to see that whether your refrigerator running, refrigerator is a thing. But you are not sure about actually whether you have switched on in your iron now or not. Sometimes after ironing your clothes, actually you may, the busy life, you only leave to the office, but after that you are thinking that whether I have switched off or not. To avoid the risk, you want to switch that breaker that connected to the particular iron. But if you have the Internet of Things, that particular iron that is connected to a particular socket outlet, if that particular socket outlet, your switch can be managed, it's a thing. If you can manage via your smartphone through an app, this is called the Internet of Things. Right? You can see that Internet of Things, you can use many areas. In a civil engineering, like the sensing, water levels in irrigation systems, what about like your pumping water level, etc. You can use it, right? And it's a blockchain and the decentralized systems. Blockchain is particularly, it is a ledger system. What do you mean by the ledger? Ledger means it records certain data. It may be financial or asset data. So you don't want to keep it everywhere as one place. So you can bring this data in a part of the, for example, say your data in a particular room, that what are the things available, you can use that data not in a one place but many places. And of course, edge and cloud computing. Actually, edge computing a little bit advanced, but everyone knows that what is the cloud computing. Cloud computing means, for example, now if you work somewhere, now you don't need to keep a hardware for computers. You can use only your PCs. You don't need servers. You need what? You need only, that is a switches to be connected. Because everything you can run in the cloud. You don't want to give the big servers, so server farms. You don't need it. Right? In a cloud computing. Now, for example, if you are working now, what about? So you all the pumping data and the other things that is you can store in your server room. Then you'll have to manage a server. To manage the server, you need actually expertise, competent staff, skilled staff. Now, in the water board, it is not your job. Whatever it is to provide the water service to the customers. So you can store these data, you can manage this data using a public or private cloud. Right? But to do that, you need what? 5G connectivity. Forget about the 5G, you need the connectivity. The connectivity means actually how these 5 stations are connected. It means actually, for example, say you have a machine, how you can going to connect machine to the other one. So what is how you can get the access to the internet? From home now, I am now delivering this lecture from my home goal. Now I am actually doing this lecture in veranda. In a wireless. I use a Wi-Fi Then from the Wi-Fi to fiber, I have the fiber to home connection. If I have the 5G connect, if you have the 5G connection, you can do it easily as well. Okay. And augmented real and virtual reality and green technologies. Now, why choosing the right technology matters? Why choosing the right technology matters? Why choosing the right technology matters? Sometimes I know, mostly the government departments, they have spent millions and the billions wasting public money without evaluating or without assessing the technology. Kindly note that we should choose the appropriate technology. Sometimes because of the other department, they get the technology, we need to use the technology as well. But that is not the case. But we will use the right technology. That is what is fitting for us. Right? And we'll have to properly evaluate it. Actually, if we choose the right technology, it should enhance efficiency and productivity. The second point, it provides a competitive advantage. And for it's a business-related company, it's a service-oriented company, it improves the customer experience. And it should align with your business goals. If you're using a technology, how we can gauge is the right technology, it should enhance efficiency and productivity. And it should provide a competitive advantage for you. Otherwise, if you don't have any advantage, why should you buy it? The dear friends, I know that most of the government departments, they do it. That's actually our government department, they're going to bankrupt it sometimes. Right? I have seen that they sometimes they bring the very high technology in some certain areas, but only those technologies are not used even. Right? When I was working as a consultant for the ADB project, I have found that there are some equipments bought by the Sri Lanka Railway uh, which means the digital multiplexers. Those digital multiplexers, even railway actually they did not want it. Those are carrier grade telecommunication equipment because railway is not a carrier grade telecom operator. It is a railway operator. They need a small bandwidth compared to the carrier grade telecom operator. They spend billions of money. Actually they were lying in Anuradhapur area without being used. Now after that, what happened is now they are time. The particular Indian manufacturer says now these are obsolete now. So he's a public money. They are wrong decisions. If someone in the railway department, I can tell the whole story. Right? It should be investigated, of course, because finally we pay the taxes. How to select a technology? The first thing, as you select another resource, technology is also a resource. Technology is nothing but another tool that will enhance our efficiency, that enhance our competitive advantage, that gives our benefits, the customers, right? First thing, we have to identify the need. Now, for example, if the particular company is growing their customers, now all the customers, you have to keep a customer database, your small machine in the office. But when you issue certain products, when you have many products, you cannot keep everything in your computer in the Excel sheet or Microsoft Access. Instead, what you have to do, you need a large database server. Then you have to decide that, okay, I need that particular database system, an application. So you define requirement. You research and compare options. Then you can see that normally when you are customer oriented company, you can say the customer CRM system, customer relationship management system. In a transport network, of course, you can have the transport, it means the passenger information systems, etc. So you have to go with the research papers. You can find a research. Here, research means not only research papers, you research it everywhere and compare the options. What are the best technology? We can impart it and consider the compatibility with us. Sometimes you bring new systems, but still existing systems are there, that you can connect those things. Those mistakes done by any department, but after that, what will happen? What happened really? That you had to pay more cost for integrating these systems, right? Now, assess cost and ROI. We want to assess the cost and ROI, right? Return on investment. Now, these are the things I ask you. Okay, this is slide. Now, how to evaluate technology? Now, you can see how to evaluate technology and criteria. When you, now I told you, first you identify the problem, then you decide to use what is the technology. So, technology is an investment. Dear friends, please note that that will not come at a cost, come at a cost, not come at a zero cost. Okay? Right. Now, criteria, technology, right? After you decide it, sometimes some people, they want to go for automation without knowing what is the automation. Right? So you have to understand whether your problem will be solved after automation. Then okay, right. Then automation, how to automate it? 100% automating or semi-automate. Okay? Right. Now, anyway, after that, you can see, okay, we will go with some certain system by the customer relationship management system. Then how do you select it? Criteria. When you select criteria, you'll have to think about performance and the reliability. So you get to get the records from the past, performance and reliability. Performances. How this kind of system performed. How this system is, how their reliability. What is the reliability index? You can get from your batchmates, your colleagues that you are working in the industry, that you can call them personally, or you can write them and ask, etc. And what are the security and the other compliances? Because nowadays, when you use it, a new technology, the biggest problem is most of the people have realized that there is security issues. Because now, when you work with the Internet of Things, Internet means actually not visible. You are connected, right? Connected means sometimes actually you open your gate and keep the gate open. You will go for a trip without closing the door. So you can create a port, physical port. Another one is that another example. Now, when you go home, leave home, you can keep that certain ladder after doing some work. Your basun and the people, they came and did some work, and you can put a ladder. But ladder is actually you place the ladder facing the main road. You know, a person can easily, or not the main road, it is actually there is a bare land, facing for the bare land. Some people can come and climb and use that ladder to enter your home. That is you open it up. So this is security, and what are the other compliances? So sometimes when you use the technology, it's a detrimental to your company. It doesn't meet regulation, rules and regulations, right? Another one is scalability and flexibility. You know what do you mean by scalability? Sometimes you buy a system, the small and medium entrepreneur buy a system that is used for the corporate. Huge system you bring it. What will happen? Huge cost you dumped it. And your flexibility. Sometimes people buy this what do you call systems, flexibility is not there to upgrade it or enhance it. Not upgrade, you can increase the capacity. And another one, user friendliness. When you bring a system, these are your operators will work. If that it is not flexible, what will happen? People will come and complain this our bosses brought this system after attending to the factory inspection in various countries. And finally, what will happen? Actually, they say they ask us to work it. අපිට ගෙනල්ලා මේක ඇඟේ ගහලා ඒගොල්ලෝ මාරු වුණා. That's why most of the time innocent staff they are telling it. They are working with the systems. They are working with the technology. And another one, vendor support. Some vendors, they appear even in the tendering stages, but after that, they will vanish it. Even they don't have a branch in the country. So then those are the things you will have to understand. And cost of ownership. Sometimes you will buy things at a low cost. Samahar vita that they will come and play with you. They are very shrewd and they tell, oh, this is a very good system. This other one is cheapest when you buy it. But there is a hidden cost, a licensing cost. When you don't want to operate it, you will have to add license. So then those are the hidden costs. So therefore, you have to think about total cost of ownership. Those are the criteria. And what are the tools you to test it? You can do the SWOT analysis and pilot testing. That is very important. If you are not sure, you have a lot of uncertainty means the risk. Then it is a pilot testing. Then best thing is after doing the pilot testing, you can get the shareholder or stakeholder feedback. What's our conclusion? Technology drives innovation and growth. It understands the trends, support decision making. Selection and evaluation are key to success. Right? Those are the things. So here, technology is evolving since the old ages. Technology में आदि वितरक के निकाल नहीं. Today's technology will die tomorrow. Technologies have been developed from the discovery of scientific things. Humans have an advanced brain among the living beings. They find the ways and means to find the solutions. Okay, Kumar, right? Good that you told me. I think just now I seen the message. I feel sorry about it. Okay, here we go. Okay. Now artificial intelligence. I explained this one. Serverless computing, actually blockchain and robotics, natural language processing, etc. Right. Now, actually, those are the general things I want to cover. But today I will add another presentation recently prepared, that is a digital twin. Hope you have know that this one. Wait a minute, I will share the screen first. Stop sharing. Stop sharing now. Now we will share once again. Okay, I will share the once again. Here we go. Right. Again, I will go to the right. Digital twin fundamentals. Right. You know, digital twin, what do you mean by the digital twin? What do you mean by the digital twin? Okay, little bit think about it. You know the meaning of the twin. Okay? You know the meaning of the thing. Right? Digital twin is what? It is a virtual model of a physical system process OSS that can continuously receive data from real world sensors. IoT SCADA or meters and simulate the behavior in real time. Right. I will tell this example. Now, when you want to construct a building, the first thing is architect should decide what kind of building will be suitable for you. What they do normally, they will give you the architectural drawing. So then the structural engineer will give the structural details. Then electrical engineer will come and give the wiring details. A building management system engineer can give other building management system requirements. Now, those are the things you can see from the different drawings. But actually, the digital twin, how you can do that? Then you can understand. Now, using a software, normally architects, they use the Revit software tool, then they can visualize this model, the 3D view. Then actually engineers can include embed the embed structural details, wiring details, and other devices to be connected. And you can have a real model that reflects your actual building. So all the calculations, all the parameters you can do use in the software. Right? Now, when it comes to Now, in the construction stage and design stage, and the construction stage and operation stage, what you can do, you can use this data, this model, right? Now, this model you can incorporate with, integrated with, it can be integrated with your Primavera project management tool. So if you set that particular project management tool based on the milestones of the project, what you can do, you can see after this milestone, my foundation is ready. Again, you can see how it looks like. So you can predict. So this should be the foundation it looks like. Right, after finishing, you can see that, that model using the digital twin. So it means you can connect these things. Right? So then you can come to certain stage, the construction stage. In construction stage, you can see the list look like this. Right? So then in the materials, the BOQs, other thing you don't want to prepare by your manual because it is in the digital twin program. You give it, right? Even after when building comes to the servicing stage, you can use drones to detect some cracks. For example, if you see a bigger crack, that particular crack can be detected by a drone. A drone can send a message via the interface to the digital model. Your digital model can say that this crack is not a design defect, maybe a material problem, etc. So for this purpose, you need AI. AI means you need the machine learning. You need data you have to exchange data. So you have to fix the systems. For example, when the building is running, now how you can manage? Nowadays, actually we have some, most of the countries have the conventions. Your carbon emission should not be allowed for any building even. It is a maximum allowed carbon emission. So some countries, they strictly follow, you must have the green energy. So you can fix your solar panel. So physically you can fix it. After that, using the solar panel sensors, you can fix the IoT device. You can have that device to be connected to the sensors through internet, your digital twin. So in a digital twin, you can go to the digital twin and work out what is the consumption now. So I am effectively using the sun light. What is my carbon footprint? So how I should optimize these things, right? This is finally integration of machine learning, communication, IoT, etc. All right. Now, its a definition goes as it's a virtual replica of a physical system integrating with the real-time data. It's a real-time data transmission. What are the key elements? Physical asset, digital model, data connection, and analytics. You need physical asset like a building, now this can be applied to a motor even. Yeah, when you want to design a motor, right? And before designing the motor, you can have your replica, right? And you need the physical asset. It's a real car. And it's a digital model, it's a digital twin. And in between the data connection and analytics.
Okay,
Why it matters? Better design, monitoring, and decision making. Hope you understood it. What are the fundamentals of digital twin? One is the core components, like the physical entity, virtual model, and data linkage. Now, what are the enabling technologies? IoT, because you need IoT. Some people got confused that IoT with the machine learning. IoT is a hardware device that can that can be connected your sensor to your system. For example, in your refrigerator, it supports IoT. Your air conditioned machine, when it supports IoT, actually IoT means it is ready to connect to the internet. It means your refrigerator or air conditioner, it can capture the data and data ready to receive for the remote location. It is really data acquisition. We call it data acquisition. So enabling technologies like IoT, artificial intelligence, you need sometimes cloud, not sometimes, and BIM, which means some people call the BMS, or building information system or building management system, and virtual reality and augmented reality. Types, components, twin system, life cycle twin, etc. Now, smart infrastructure, bridges, dams, roads, with structural health monitoring. Now actually you need structural health monitoring, like our body is monitored and measured and monitored. In sometimes the dams, of course, you have to monitor whether there are fatigues, the cracks, structural failures, etc. When it comes to the construction management, building information management system plus digital twin for planning and cost control, I told you about. When it comes to energy, it is the sustainability, energy efficiency in smart buildings, right? And highway digital twin for traffic optimization. This is for the civil engineering applications. Now, it comes to the mechanical engineering applications. The rotating machine, you can predict the maintenance. Turbine pumps, compressors. And manufacturing process, optimization, because manufacturing process, you have to optimize the processes. And additive manufacturing. Then automotive and aerospace with crash simulations, fatigue life predictions. And another one, the jet engine twin, reducing unplanned downtime. Those are the mechanical. And it comes to the electrical engineering applications. And power systems, of course, Grid stability, renewable integration. This is a very much complex subject. Everyone knows it. Sunny Sunday, we faced a blackout in recent past. Because renewable energy integration means the renewable energy, we connect the renewable energy with the low inertia. If by chance, if when the renewable energy, when it used in the peak, maximized, at a situation, if a transmission loss, the system can be unbalanced because actually due to frequency problem. I think someone, please engineer, BW Kumar, please switch off your mic. Engineer BMC Kumara, please switch off your mic, or I can mute you. Right? And electrical machine monitoring, motor performance and fault prediction. Wind farm twin for predictive energy. Right. And wind farm twin for predictive for energy yield. Now, what are the cross-disciplinary benefits? Safety and reliability, early fault detection. Any discipline. Cost efficiency, sustainability and collaboration. What are the challenges and limitations? In data security and ownership issues. Because your data should be properly secured. And implementation cost is very high. At the moment, I know in civil engineering, we use the Revit software. The Revit software is very expensive. And again, skill gap. Most of engineers, they don't use it. And it is difficult to integrate with the legacy systems. But future trends. AI-driven autonomous digital twins. You can have AI-driven. And integration with immersive metaverse. Adoption for infrastructure, power and industry projects. Membership exam preparations. This kind of exams also we can prepare using the digital twin. What is our conclusion? Digital twin is nothing but engineering and data plus intelligence. Three key ingredients. Key to future-proofing the profession. Encouragement for adoption in design, operation and reforms. Those are the general things I want to cover today. Okay? Is a time for asking questions. You have questions, is it clear or not clear? Please raise your hand and ask questions. Do you have questions, please? Have questions? Any language you can ask question on this problem. Single or you can ask. I will share one presentation with you. Actually, it is not prepared by me, but one presentation done in an international seminar. And one of my friend, actually, I got his permission to share with you for the educational purpose. It is how actually they can manage the cost and construction manage using how can I say, using digital twin. Okay. Wait a minute, I can see whether I can have it here. Give me a couple of seconds. This is PDF document. Here, sharing. Yes, here we go. Right, here we go. Construction dynamics and digitalization. It is one presentation. Actually, that is aiming at a particular seminar, international conference. The names I said recently concluded. We go to the next page. Now, it says problem. What is the problem exactly? Traditional manual and AutoCAD 2D drafting is constrained. With analog workflows that are fragmented, can only take reactive decision with the limited transparency. Right? That particular author, that is, he has brought these two diagrams. One is a bird's eye view from the Putrajaya Mosque at Malaysia and Central Dome in upper view. Right? He created these two models using, before constructing, they use it here using the digital twin. Right? Now, again, there's a net zero carbon goals. Now, some other countries, they have objective to show how the digitalization reshapes construction, operation, and maintenance energy optimization, achieving environmental sustainability goals. So he has listed out. Now, when it comes to, sorry, we go to advanced right in here, case study. This is the EPC contract of Maldives International Airport. So, you know what is the EPC contract? It's a turnkey project. Now, methodology, you need to deal with the multiple disciplines like structural, mechanical, architectural, airport system to create data-rich ecosystem with AI LOD specifications. Right. Now, case study, again, use a digital twin model to resolve the interface issues, clash detection virtually by federating the building model with the airport systems. This is a passenger boarding bridge digital twin of the system manufacturer. You can see this is created beforehand. Now after that, here by modeling the solar seasonal trajectories, how the heat gain inside with the building and how that covering western side with the facade blocks of the filters sunlight saves 7 to kilograms carbon dioxide per day. Now in the project management, connect in digital twin with the Power BI node, no code, low code platform and Primavera database dynamically evaluate the KPI in accordance with the PIMBOX, the project management, how it used. And here they can say that artificial intelligence algorithms and Power BI automate tasks like the data preparation, cleaning, and analysis. They can update the cost at any time. Now, what are the lessons learned for the future map? Advantages of digitalization. The digitalization enables easy visualization of design scope, even for non-technical stakeholders. And clashes between systems can be virtually detected before construction begins. Sometimes we have to wait till the construction will complete it. And construction progress can be visualized against timelines. I explained you. Number 5 is IoT sensors, digital meters, AR/VR devices provide dynamic data for monitoring and sustainability tracking. Digitalization supports the creation of life cycle data ecosystems. Then what is the future roadmap for our country? Universities should collaborate with the industry to launch joint research, pilot projects, and skill building labs. Graduation engineers must be equipped with a strong digital fluency to meet industry needs. Sri Lanka Building Information Management Guideline should evolve to integrate the digital twin technology. Digital twin technology, it should be brought as a regulation. Now actually we don't want to keep most of the carbon copies, which means the blueprints, etc. We have the digital archives, we can keep those things. And large public projects and success stories. But this is from the case study. It's not my presentation. One of my friend did this presentation. I hope you got a good idea out of this. This lesson is not to teach that is what is the appropriate technology that give a deep understanding of each technology. But I know you know better than me sometimes some technological applications. My duty is to tell you about how the technology is evaluated, how to write the right technology, and what are the key technological concepts. Hope you understood everything, or if you have still questions, I think you may have a lot of questions. You can, it is now, it's time to ask questions. You can have, if you don't have a question, I can wind up. I can wind up the session. Is it clear or not clear? Right.
Sir,
Yeah.
it's not about the lecturer, sir. How about the questions to be asked in the examination, sir? Is it
These
uh,
are open questions.
open now? Okay, not a theoretical.
Because I cannot ask a question that what is this explain about the digital twin technology. Or I cannot ask IoT technology.
Uh,
You must know that how this question is related to the open case. It includes management, selection of technology. It includes many things. Sometimes your answers may be different. One person say this is the best technology, another one is this is my opinion. This technology is bad. So that is you have to bring your logic there. Okay,
Sir, who makes the questions?
that is I cannot say because actually examiners in the credentials I cannot divulge it. But there is a syllabus. We do the syllabus. We do this presentation based on syllabus. Anyway, did you understand what I taught you? Is there
Yes, sir.
anything? If anything is not clear, let me know. I will share this digital twin use case and these two presentations. Okay?
Can you share the yes, sir, presentation?
Yeah, sure, sure. I will share it. Okay, then if you don't have any questions, wish you all the best for the exam, and I will wind up it. Okay?
Okay, sir.
Okay, thank you, sir.
You're welcome.